Cool. Can people hear me? Sweet. All right, well, we're going to start with a little bit of an interactive thing to see who would like me to first go into a very high level of what AI is and what it can be used for, just in very general terms before we get into AI for good, or dive right into AI for good. So all those in favor of AI, I don't know, overview, very quick, raise your hands. And all of those in favor of diving into AI for good first, raise your hands. All right, the former has taken it. So, all right, hopefully this is not too dissimilar for a lot of people, but basically what I'm going to go through first is just give you a basis of what I mean by AI, what it can be utilized for, and then we can go into some of the depths of like some practicalities of using it to impact society in general. So AI, why now? Okay, it's used for lots of different things. There's a lot of business use cases. There are a lot of use cases in our everyday lives. There's more and more data, and the hardware that we've been developing also really helps, you know, mold those two together to get solutions to those who need it. Okay, so lots of business, operational, security insights, as well as helping day-to-day live stuff. So what do we mean by AI? AI basically is any type of algorithm that can take in information from the world and then do something about it. It can recommend something. It can say, hey, I see you're reading, well, we were talking about Harry Potter because I love Harry Potter. It says like, hey, you read a lot of these books. Maybe you want this other series, The Magicians. It's like, I noticed that you're actually a grown-up. Well, no, grown-ups can read Harry Potter, but you know, it's stuff like that. It's driving directions. It might be knowing that there's construction right out front and saying, hey, it might take you a little longer to get to the building, etc. And it could be other things too. So what's showing here is, you know, just a simple classification. And there's basically like two parts to all types of training. And when we talk about AI, it includes things like machine learning and deep learning. And I'll go into the basic difference between those two fields in a second here. But for both, you're gonna have, and this is for labeled, you'll have some sort of training session where it's saying, hey, I have all these different samples. This might be images of stuff. So there's a canonical data set that a lot of people use called ImageNet. Basically pictures of things that you can find online and say, hey, this is a cat, this is a dog, this is a hot dog, etc. And then when you have inference, you're taking your trained model. So your trained algorithm that says, hey, I know how to take both labels and things and then label new examples of this. So it's able to take a picture of a bicycle in this, like, you know, pictorial example and predict that, yes, this is indeed that. And it'll also give you, in good state, you always want it to also give you how confident it is. Because one of the big things that is often misconstrued about artificial intelligence is that it might be this infallible system, that it's perfect, that it like knows all the right answers all the time, and that's not the case. So, you know, it can make mistakes, and knowing how and when to intervene when it makes mistakes is really, really important, and we'll get into that a little bit. But there's a lot of different approaches, and there are a lot of different algorithms. So these are some of them. You basically have things called unsupervised learning and supervised learning. When it comes to something like machine learning and also AI. But unsupervised learning, what you can think about this is I have more of a background in natural language processing. So I'm going to pick on that for a second. You have these techniques where you might have a whole bunch of different text, let's say, and you're trying to figure out news articles. And you know that, you know, there might be 20 different topics that are generally talked about in the news every day. It might be sports, it might be science, it might be religious topics, it might be politics or world affair, economics, those types of things. But you don't necessarily have article, what its topic is, article 2, what its topic is. But what you can do is something called unsupervised learning. And this is what you can do there is sort of say, okay, I have all these text documents, and I want to cluster them. So this is a type of clustering, and a lot of unsupervised learning is clustering. There are some other techniques, but you might sort of say, okay, algorithm, figure out which of these documents go together. And it might not say, oh yeah, this cluster is sports. But you can look at, the top words that might be in that cluster. You might look at the top articles and then be able to then label it yourself. That's sort of something that's also known as bootstrapping. And bootstrapping is something where you sort of piggyback these various approaches onto each other. So you might start with an unsupervised algorithm, and then you go to a supervised algorithm, etc. So yes, lots of tools. I am going to be talking a little bit more about AI, which is all deep learning. I don't see, oh, there you are. There, neural nets. And I guess you can also use neural nets for unsupervised too. So they're everywhere. And the biggest difference between machine learning and deep learning is figuring out your features. So let's say we're trying to identify who this person is. And I really should update these slides because that's not often the best thing to do with AI. But anyways, so let's say I'm trying to figure out who this guy is. And he's my boss, or my skip level manager. And what I could do with a machine learning algorithm is say, hey, I know that his eyes are, so far away from each other. I know that his nose is so far away from his eyes. Or these are the various features that let me understand who one person is versus another person. And this is called feature engineering. So I'm telling the algorithm which features to look at to find a roundness of a face when it finds the edges, to figure out, like where is the hair, what is the color of the hair, stuff like that. And then I feed all those features into a classifier algorithm, and it says, yes, I know who this person is. Versus a deep learning network, you don't do this feature engineering. The network is both figuring out how to do this classification as well as which features are the ones that are most pertinent to itself. And a cool thing about like the networks is that we have started to be able to figure out what do each of these they're called hidden layers, what do they do? And basically each one of these layers often figures out more and more complex layers. So this first hidden layer might be saying, hey, I'm an edge detector. I am figuring out where there is a change in the pixels. It's dark here, it's lighter here, etc. And then the second layer might be, figuring out edge detection in the other direction, and then they start to form shapes and textures, etc. And over time, it learns what is important when I'm trying to do this task, and then how do I train myself to do it, which makes it pretty robust. It's easier to use in a lot of different situations, which is quite powerful. So basically, it's being used in a lot of different applications across many different diverse domains. We see it a ton in image classification in particular, so these computer vision types of challenges, mostly because the data is very large, but it's also mostly structured. A picture is basically just ones and zeros displayed in a grid format. And if you have RGBs, then you have a matrix, a 2 by 3 matrix, where each RGB is a different channel. Sorry, I might have lost y'all on that, but I do have a whiteboard, but did I really lose anybody on that thing? Ish. Yeah, okay, sorry. So your data, so basically when your image comes in, let's say it's a very bad image, it looks like this. So this picture is basically just sort of saying, this is like a black and white picture, so it's gonna have like, you know, this is 0, and maybe this is like his hair, so it's like, well, it's not a 1, but it's usually something between 0 and maybe 250 or 260 or some upper bound level, etc. And then, you know, that is how the computer is looking at the image. And if you have an RGB, you basically just have 3 of those. And RGB means it's a color image. And that's basically like how the printing press was originally used. You know, you had a red layer, a yellow layer, and a RG, green, and then a blue, red, green, blue. Yeah. I can do acronyms. And so you stack those 3 on top of it and you can get any color, which is really cool. So yeah, that's how the computer is reading it. And it's found to be very robust. Oh yeah?
Quick. You know, when we talk about, you know, this image analyzing, is it something like the system will take into input on only one type of images, or is it like I could give a sequence of images, like, you know, one of a person, then an animal, maybe a bike after that?
Oh yeah.
And then it'll keep on, you know, kind of, you know, identifying that this is a bike, this is a person, this is an animal. If that is the case, then is there you know, an external input also that is required to tell it that, okay, now the image that has come is of a face, now the image that has come is of an animal, now...
No.
How does that work actually?
That's a really great question, and it doesn't require you to tell it like what is the image that you're like giving it. So this ImageNet data set that I mentioned is a really good one to like sort of start out with, because it does have images of all sorts of different types. And basically what this is going to do is it'll have an image of a bike, and it'll say this is a bike, and it'll have an image of a person, and it'll say this is a person. And those lower levels, I wonder if I have a good, yeah. So this sort of talks about what I was mentioning before, where every layer learns something. So like all of these images, no matter what they're taken of, have some fundamental similarities in it, that they all have what's known as edges, maybe, and they have like different textures. And the network, when it's figuring this out, it's able to find those features, these like low-level features and these higher-level features really well. And then what this layer at the end, this fully connected layer, or whatever is at the end of your network, because what you can think of as like a neural network is it's just a bunch of different operations, all stacked on top of each other, each one having its own like different job, basically. And our fun thing is then to be able to like mix and match them to figure out, oh yeah, you know, this is the thing that I want to do with it. So it's able, if I gave it pictures here, this example almost talks exactly to what you're saying, is if I give it pictures of faces, cars, elephants, and chairs, and when I'm training it, I have a label for each of those. So the network is able to like do this multi-label type of classification, and that's done a ton, which is really cool.
And it automatically then determines what weights have to be assigned to each of those, intermediate nodes over there.
Yep, yeah, exactly. That's done during the training process.
So
yeah.
If I have a picture of a mug with an elephant down on it,
I don't know. That's a really great question. It sort of depends probably on if your training set had images of mugs and if it had images of elephants, you know, and what you were training for more of the time, because it might do either, and it might do both. So
depends on how you label it.
Yes, exactly. Yep. But great question. Cool. So let's see here. Some common deep learning models is taking an image and saying what the image is of. So this is that example that we've sort of been talking about. You can also do something around like reinforcement learning, so, or other types of applications where you have an image and you take an action. So this might be, there's some really cool videos out there of like robotic arms learning to grasp. And so they know what their current state is, what, you know, the area that's around them, and they're learning how to pick up things. There are ways to start to caption images as well. And I love this example because it's a great way to make certain that everybody can interact with our environment in a way that is meaningful and full, no matter what their vision capabilities are at the moment. And you basically combine advances that are being done with imagery with advances that are being done with text generation as well. And text generation is getting better and better, which is both interesting to see, and it's also like, you know, has created a little bit of fear, like the, if you have a language model that's, well, both of them, you can start to create synthesized text and synthesized imagery and videos, which is, can have some issues, but it's also really powerful too. Then you can do, one of the things that's often done is either bounding boxes and categories. So this is, there's a technique out there called YOLO. I have no clue what it stands for, but yeah. Oh, really? No. Is that what the network is called? What? Yeah.
You only live once, yeah.
Oh, wow.
That's one I know.
That's the I guess the fun you know.
The fun one.
Yeah. So I don't know from an AI perspective what it is.
YOLO from the algorithm is going, you only look once with things
Oh.
that only looks once they use and doesn't repeat again.
Check, you only look once. That makes a little bit, I like you only live once, that's true too. So YOLO and tiny YOLO are used a lot because one of the big powerful things with them is that they're able to do a lot of different classifications all at once. And there's some cool videos out there that have like, especially driving videos that say, hey, car, person, tree, person, stuff like that, which is cool. And it's super fast and it's like fairly accurate. Then you can now take this one step further. If you're able to figure out these multi-object classifications, you can start to do even better scene recognition. So you have different sentences and you can put together a story of what's going on in the area. Or segmentation. Image segmentation is one that's really useful, especially in the medical domain. So a lot of instances are starting to use this to help radiologists look at scans, like CT scans or other medical types of situations, being like, hey, look here, there's something going on here that you really should check out. Cool. And then, let's see here. With text, you'll have different types of classification. So that might be that news classification type of instance that I spoke to briefly. Translation, you know, we are getting better at translating from one language to another. Or like language modeling, you can start to create text as well as describe scenes. You can start to figure out, these are used in a lot of chatbots. So if you have like a question answer type of system where you're wanting to provide help to individuals, it can take some of that burden. And yeah, and then like speech to text. So if I'm talking, I can have like what I'm saying down below in closed captions. Yeah.
So at this point, is AI advanced enough to where it could impersonate your unique speech patterns?
It's a great question. Sometimes it can, sometimes it can't. It sort of depends on who you ask, if you think it is good enough to impersonate. But then there's also like, if you have more unique speech patterns, then I think it'll be harder for it too. So there have been instances where, I've seen videos of people being fooled that there is an AI there, but a lot of times you can still tell that it's a computer talking to you. So it's a great question. Oh yeah.
This is a bit of a strange question maybe,
Oh,
but
yeah.
if you fed like all the information we have about the world into one like AI, would it be able to write a book which could like comprehensively like describe how the world works?
That's an interesting question. I haven't seen anyone try that. I've definitely seen people feed in a lot of text, especially in different types of prose. So seeing, computer-generated Shakespeare or computer-generated, there's some Harry Potter. There's some computer-generated other types of text. And it's interesting because usually the sentences that you're reading, they make sense mostly linguistically, but they don't make, you have all your nouns, you have your verbs. The sentence structure is there, basically, but it doesn't actually make a lot of sense to you as a reader. So it's not quite there yet, but that'd be a fun experiment to try, so yeah. All right. I am going to switch over to my other slides and talk a little bit about how you can use all these techniques for AI for good and how they're utilized. And sorry if I went too fast for those who wanted a background in AI. There's a lot of really great courses. I mean, you're at Stanford, there's probably a lot here, but then there's also stuff like Fast AI or Coursera, or we have a bunch of courses on our site that I'll give you some links to as well. But I guess in terms of AI for good, there's essentially two components that I wanted to go over somewhat briefly. And one is responsible or ethical AI. So basically, we can do a lot of cool stuff. How do we do it in a way that makes sure that it is transparent, that it's not biased, that's not going to disadvantage anybody in particular, or to the least extent possible, etc. And then there is socially impactful, beneficial AI. Like, how do we support mission-driven organizations? How do we create tech that really has impact on people's or the planet's well-being? So making sure that everybody has enough food, water, making certain that our species are protected, etc. And when we say responsible or ethical AI, there are a lot of pillars. Harvard did this cool blog and visualization of some of the various ethical guidelines that are out there. In each one of these rings is a category of an AI principle. So you have things like privacy, accountability, fairness, transparency, human rights. And each one of these spokes is a different principle. So some of them come from entities like ACM, IEEE, these large conglomerations of organizations that have come together and defined, how tech should be utilized in the world. And then there's organizations that are popping up more recently, like the Partnership on AI, Data for Democracy. Then there's a lot of them. So it's a great place to go start and think about this. And it's a very hot topic. There's this towards data science. It looks XKCD-ish, but history of fairness in machine learning. So this is something that the ML AI community has been talking about a lot and has really grown a bunch. And I don't know if it was necessarily LO fairness and then oh crap, but you see a lot more papers on this. But the conversation is ongoing, it's complex, and it can be heated sometimes because we all have our differing viewpoints and opinions, and it can be even harder in practice. So I don't know if anyone watches The Good Place, but there's great scene where, this character in the middle is put into an ethical dilemma, in an actual ethical dilemma, and it's really hard for him to choose what to do. This is like the canonical trolley problem in action, in a very realistic simulation, basically. So what do we mean by fairness? This is sort of the mitigation of bias, and it's really interesting because in machine learning, AI world, fairness often, or bias, means that there's systematic errors in a model's prediction, meaning the algorithm just doesn't do really well in this scenario, or it goes one way or the other. When we talk about this in a social perspective, though, it's saying that there's maybe preconceptions of a person or a group of people, and that can lead to like these systematic advantages or disadvantage to individuals, to groups of people. And so when we're talking about fairness in the terms of algorithmic fairness now, it's like the fact that there can be these systematic bias in our algorithms which mirrors the inequalities that are happening in the real world, potentially, or exacerbating them, etc. And these subpopulations are often defined by protected classes. So they might be age, gender, race, etc. Socioeconomic classes. It's something that it can be really concerning. Probably a number of you have heard about a study a year or two back, maybe a couple years now, done by ProPublica, where they found that these recidivism models, so basically when you're there's a number of algorithms out there actually that are saying, hey, should you be let go from jail, or are you at risk of reoffending, basically? And what they found was that the algorithms were not very fair. They had a much higher accuracy of predicting correctly for white individuals than they did for African Americans. And that really affects, the people who are kept in jail unnecessarily. So this is one of the reasons that this has really come to the forefront. The other reason is that when ProPublica did this analysis, they also open sourced the data set. So now with this new data, there's a lot of work that's being done in the area. And it's interesting. Yeah.
So what is the input for this?
Yeah, and that's also complex, because what's interesting is that the algorithm that they were testing it on is a black box. So what I believe they did, and probably check out the actual study to make certain that this is correct, is that they looked at individual offenders and reoffenders in Florida. So they had information on age, race, gender, who they were, etc. And then they were able to put that information through the algorithm, into the system, and get a prediction, which was a number from 1 to 10, which corresponded to low or high risk. So things like that. And I believe that there's definitely other things that go into this, such as where you live, your previous offenses, but even things like who and where you live, like that takes into account also like who lives in that area and what is the offense rate there, stuff like that. So it's a lot of variables. Yeah. And most of us never touch recidivism, or write an algorithm for it, or even think about writing an algorithm. But this bias is actually fairly pervasive in almost all the data sets that we might use as AI practitioners, as data scientists. So one of them, this is a really interesting one, is that last year there was a NeurIPS challenge called Inclusive Images. And basically what this was hosted by Google, I believe, and they figured out that the Open Images dataset, this open source dataset, is very geographically skewed because how we get these datasets is we go online and we're like, hey, I'm going to scrape Instagram or I'm going to scrape Twitter because they have APIs that are open. You've already agreed to like share your data, so I can get all this information, or go on Reddit or whatever. But the people that post their pictures to these sites are often from the West, you know, so we are putting images of ourselves, of our friends. And what they found was like, you know, because there's this geographical skew, there's a skew in what these algorithms are being able to predict. So this image on below shows how an algorithm classifies various weddings. And if you are, you know, a Western bride, you're often in a wedding dress, a white wedding dress with a veil, etc. If you are a bride in Africa, you are not doing this. You are wearing a much different outfit. So the algorithm, even if it gets like a few images of like African weddings or like Indian weddings with like the traditional beautiful saris, it might not classify it as a wedding. It might be, oh, people, person. And like, okay, it's not so bad, but it's not so good either. You know, like this is one of the moderate examples, and there's other ones that are like way worse. So you want to look out for this in like your algorithms and your data sets basically. And this happens in text too. And basically what happens in text as well as images is that like these underlying biases or these underlying types of norms that occur in society get into our data set one way or another, where we have potentially less sports classification is actually a really great example of this, where I don't know who, but they there was an image of Barack Obama, you know, throwing around a football or something. They ran it through a classifier, and the algorithm said, oh, yeah, this is basketball, because he's African American. So, and they play basketball. They don't play football, but that's not really true. It's just like sort of what has been held in our society in the past, and the algorithm is just sort of perpetuating that. And so this just creeps into our text. One of my favorite / least favorite is this paper, man is to computer programmer as woman is to homemaker. Like I was talking about these language models, and basically what you can do is an unsupervised approach of saying how words are similar to each other is by saying, okay, what are the words that are like around me? And you can create these vectors, basically, multi-dimensional vectors of words, and you can start to do like vectors addition and subtraction, so you can get these like SAT-like similarities between them. And if you take the representation of man versus woman, it's the same as king versus queen. It's like, okay, cool. You know, it's figured out a gender vector. And the same like vector math though works with man versus woman and computer programmer versus homemaker. And it's like, sad. It's like, well, I'm okay with the top one, but I'm not so cool with the bottom one. In society as a whole, I would hope feel similar, but you know, sometimes we don't. And that's also chill, because we all have our own beliefs, you know, but it's interesting, and that can perpetuate. There are some papers that are saying, you know, like this may or may not be true anymore, / I don't know. We're not gonna get into this, but bias is bad, and it happens in your algorithm, so yeah. Just take that away. The other real complex issue, though, beyond just the fact that how do we figure out what is bias and not, is that there's a lot of different measures of fairness. So this tool came from the Data Science for Social Good organization out of University of Chicago, and it just mentions 4 of the various fairness measurements that you might want to use, and there are more. There's probably around 21 of them at the current moment. So what is fair, what is not fair is something that has been discussed by many people for many, many years. And it's complex. Sometimes you might want parity, which means, you know, like I have equal representation of, you know, men and women or something in my data set. And sometimes you want something different. We're just gonna skip that one. No, it's important. I don't want to confuse you all too much either, though, is that sometimes if you pick one measure of fairness, it can actually hurt who you're trying to help more than another measure of fairness. So it's all about testing and thinking about how is this going to be used at the end of the day. So like really creating the algorithm with care. And there's a lot, though, that you can do to make it more fair. And just by starting to ask yourself the question is a great start. Because there's no magic answer. There's no silver bullet, no like algorithm that's going to solve it all. You can start by looking at what are the potential sources of bias here? Are there any ways to mitigate them? Can I collect more data? You know, like, can I de-bias this or mitigate the bias in some way? And talk to a lot of people. And then look both at what's going into your algorithm and what's coming out. And then this last bullet, counterfactuals, is pretty chill. Basically, you can see how a prediction might change given a variable change. So if I'm a loan applicant and I'm a male versus a female, how does that change how much money might be lent to me, et cetera? And there's a lot of tools. One of them, there's two here that I wanted to point out in particular, is like IBM has a AI Fairness 360 toolkit, which is really cool. It's all open source. And I have a link at the end that has like a blog post of all of the various AI ethics tool resources. And then this what if tool is another one. Both of them give you some ways to start to look at your data set in a more closely. Okay, so transparency. Basically, you're trying to answer the questions. Who's going to interact with the system? Have I included the level of information that they need in order to make an informed decision? And how was it trained? How is it being utilized? If it does something wrong, what happens then? Why is it behaving in the manner that it is, basically? You don't want something like this XKCD comic where you just sort of throw in a bunch of different stuff, answers come out, and you're like, yeah, it's cool. Yeah, it's awesome. But yeah, XKCD is great. Because really, we want to know what we're interacting with. When I was looking for images of this, I was like, I came across this, which is perfect. It's because sometimes we forget. It's like we're working with robots. We're working with these computer systems. It's like, what happens? This is by Sam Brown. I have not read it yet, but now I want to. And there's one of the misconceptions is just because you know what's going on doesn't mean that everyone else will. So you're likely going to have to include different levels of information for someone who's an interested public. They're just like, hey, I heard that there's this algorithm, it does something, what is it? Versus a user, versus like an auditor and an external collaborator, and your own team, you know. There's different things that are important to each of these different entities. But by doing this correctly, you can help increase trust, you can increase your accountability, increase like how interpretable or explainable it is, and then you can mitigate misuses or unintended consequences. And in general, like when we think about different algorithms, some of them are easier to interpret than others. Like if you have something like linear regression or a decision tree, it's pretty easy to say, oh yeah, you know, like if you have a line ax plus b, if you're above that line, then like, or if you are x equals something, you can be like, oh yeah, now I know why y equals this other thing. Versus a deep neural network can be harder to explain. It's not always the case, but it sometimes if you really need to explain what's going on, you might need to choose a more interpretable algorithm. And there's different things you can do too. So Documentation is a big part, and doing that from the beginning. There's a lot of papers on this too, as well as one of the tools I really like is Lime. This it's for Python or probably R, and it basically helps show why different things were chosen using various methods. And like I said that neural networks are harder to explain, and they are, but it's getting better. There's this cool website, distill.pub, and this is using something called attention layers, and you can start to say, okay, why was it a dog versus a cat, and start to see the features that were chosen and how they related. Okay. And there's resources that are out there. So Partnership on AI just released their About ML thing. And sorry, I don't have the link on this one, but it's a document that takes a lot of the previous work that's been done in this space and puts it into a 30-page document. And IBM also just this morning released their Explainability 360 Toolkit. So very similar to Fairness, but this one's Explainability. And sorry, I've started going a little fast, but I'm already almost going over time. And I have 20 more slides. Yeah. Okay, so accountability. It basically answers these questions, and I'm gonna breeze through the rest of these responsible AI ones. But who's responsible for how a system is used and the decisions it makes? If there's an issue, if I'm not liking how the algorithm was used as a user, how do I tell the owners about this? What is that chain? So just appealing decisions. And how does it get corrected then? Privacy and security. Basically, there's a lot in this space. The highlights are making sure that people have given full and informed consent if you're using any of their data, that there is a right to be forgotten. A lot of this is in the GDPR, a set of rules that came out of Europe. And that there is clear retention and disposal procedures. And the big ones is how much information do you really need? And only collect what you really need. Anonymizing whenever you can. And it's really interesting because even anonymized data, you can figure out who a person is. There's some interesting reports on that recently. So take care, who are the people that I'm trying to help out, and how do I make certain that they are safe and protected as well? And then making certain that you mitigate for data leaks as much as you can, because they are rampant and bad. And one interesting thing, though, that's been going on is that there is a lot of algorithmic research to increase privacy. So these four all do that: homomorphic encryption, federated learning, differential privacy, and probably blockchain too. Blockchain is actually being used more and more as a tool for many different purposes, which is cool. It's not just cryptocurrency anymore. Because you have registers basically that are harder to hack, I guess, basically. So I don't know much about blockchain, but. And then the last, but certainly not least, principle is around human rights. And the UN defines human rights as and I'm just going to read this, is the rights inherent to all human beings, regardless of race, sex, nationality, ethnicity, language, religion, or any other status. Human rights include the right to life and liberty, freedom from slavery and torture, freedom of opinion and expression, the right to work and education, and many more. So what this means to us as AI practitioners is, how do we make sure that we're upholding these rights when we're designing new tools, when we're designing new systems? And often, even with like the best of intentions, it is totally possible to disadvantage somebody or something. Like, there's no technology in our history that has been wholly beneficial to everybody and everything. There's always some type of cost there. So there's some tools that have been made to help this. One of them is this Ethics and Algorithms Toolkit. And basically, it's a set of questions that you go through by a project team. And they take a risk management approach, which is interesting. And so they have all these different steps. And they ask you questions like, how much of people's data are you using? High, medium, low. How likely is it for, X, Y, or Z? And it's there to help spark discussion, get this conversation going. Another one is Dion. This was created by a group called Driven Data. They run a lot of like AI for Good hackathons, actually, which is cool. And this is very readily integrated into your code, either in your Jupyter notebook or README or something. And it goes through a lot of questions. It's like, did you think about this? Did you do that? So basic tools and steps to integrate this into every single project that you do. And basically you're trying to ask, how can this do harm? You want to make sure that you're nurturing and fostering diversity, because the more different types of people that you have in a room, the more types of issues that you could probably think up. You're working closely with stakeholders, and there are a number of toolkits that are available out there to help you along this way. Okay, we're gonna switch gears real quick. And I'll probably be yammering for about 10 more minutes to y'all. I was told to stop now, but I have about 10 more minutes, so yeah. But this is the fun part, because this is like, okay, now that we made sure that we're not gonna harm people, how do we also have a really good, like a very large impact? And we can do this in a lot of ways. We often classify this in sort of 3 broad categories: around healthcare, around the earth, and a social impact. So I'm gonna dive into a few of these like right away. Now, we were talking about human rights and how to make sure that we're not diminishing anyone's human rights. We can also, though, use AI to help make certain that people's human rights are upheld. So oopsies. Oh gosh, this one is like an auto change. Well, I'll just keep on going back to this one. So we've been working with the National Center for Missing and Exploited Children for a while. Oh, that's gonna make me go crazy. Oh well. And what they've been facing with is that they get a lot of tips. Basically, if there is any children that might be in danger, they're notified about this. And we've worked with them to develop some algorithms to use our Xeon scalable processors in order to reduce the turnaround time for these tips from 30 days to 1 to 2. Being like, these are the ones that you really should be paying attention to. These are the ones that are false alarms, potentially. And then also, like, where is this occurring? So country of origin, degree of severity, et cetera. And it's been a really great partnership. And now we've also been working with Thorn, a similar organization. This second project also is making certain that everybody has the same access and same degree of mobility. We've been working with a startup called WhoBox, and they're a robotics company. And the idea behind this project is using facial gesture recognition for somebody who is wheelchair bound, especially someone who is paraplegic, to be able to control their own motorized wheelchair using whichever gestures are most natural to them. So they've trained up a neural network, so a deep learning algorithm, and this AI system is able to figure out using, like, there's that camera in the front, and that's actually a 3D camera that we've made. It's called like the RealSense camera, and the 3D camera is just able to get more of the nuances in the facial gestures. And there's a computer on board. I think it's this dude. That's like the Intel NUC, and it's a 8x8-inch miniature computer, and so everything runs on it. And when the person smiles, the wheelchair might go forward. Well, if that's what they commanded it to do. If they open their mouth, then it stops. Raise their eyebrows, they go left. Do a couple of different movements, like smile, and then raise their eyebrows, then the system goes offline for a while because they're talking to their friend, etc. And this is a lot less invasive, a lot easier to use than a lot of the systems that are out there, which is pretty cool. Along the lines of Earth, one of the projects that we've been working on, which I love, is called Snobot. And the idea was these researchers out of the University of Alaska and Parley for the Ocean, they came together and had this idea of overflying whales with a drone. And the drone has a petri dish on it. And the petri dish collects the blowhole emissions, the snot of the whales. And now the researchers are able to look at this like petri dish and look for bacteria, look for oil, figure out, are these whales healthy, are they not, etc. And then at the same time, you know, the drone is taking pictures of the whale, taking pictures both of like the body itself and the dorsal fin. And one really cool thing about the dorsal fin, you can sort of see it in this left picture, is that the fins are unique. So if you're able to figure out the edge, you can write an algorithm that says, oh yeah, this is the same animal. So now you're able to track a certain animal's health, which is pretty cool. And do volumetric data to see how much body mass they have, are they losing weight, are they gaining weight, etc. And this project, and just all of these, you know, is to give you an idea of what's possible. I love this project because it's working with this little computer, like it's called the vision processing unit. And this is the same chip that's in the neural compute stick that was mentioned this morning. So the same chip, you know, that you all could win next week, is being used to help prevent elephant poaching and animal poaching in Africa and other areas. And basically what we did with this nonprofit Resolve is they have these cameras and they've been taking pictures in Africa, and these are actually pictures from like the version 1 without our unit. And what we're able to do though is build a neural network and figure out, is there a person here or not? Because these cameras are super sensitive. They go off if the wind moves. They go off if like a tree branch falls or whatever, because you want to catch everything. But then the network is running on the camera itself and saving a lot of transmission time, because this transmission is having to go to a satellite. There's no Wi-Fi in the Serengeti. And that takes a lot of energy. So now the camera battery and the camera itself can last like probably for a year instead of the 3 weeks, which is super beneficial because now like the rangers aren't having to constantly change batteries. And then this next to last one is interesting. This actually comes from our AI Academy. Some students have wanted to figure out like what are the diseases in tea plantations. So basically, they took a bunch of pictures of plants in India, tea plants in India, with and without various blights, and then used image classification, simple like I think this is MobileNet version 2, and MobileNet version 2 is also one of these like types of networks that's used for a lot of different applications, and said, yeah, you know, like this is blister blight, or with a certain, you know, type of accuracy and stuff, and all of this can be done on somebody's mobile device. And so now a farmer can go out to his field, take a picture, figure out what pathogen is going on, and then get some recommendations of like, oh, you should use these mitigation efforts. And the last is that I want to go through really quickly is this student in Nepal. He's been working with us to build this app to determine what currencies are for somebody who is blind. Because a lot of currencies in the world don't have any markers on them that tells somebody who is visually impaired what they're holding. But now they can take a picture of it using the smartphone, and most smartphones these days are actually fairly accessible to somebody who is visually impaired. Like there's a lot of voice tools that they utilize. It's really cool to see, actually. And so now they can be told, oh, you're holding a 10, you're holding 100, 1,000, etc. And he collected like 14,000 pictures and labeled them himself, which is just nuts, but also important. It's like you got to get the data somehow. And yeah, he's also using MobileNet V2. So, okay, that was like a whirlwind of projects. And hopefully you got to see some of the cool things that the tech can do. And what usually happens is like a group or an individual approaches us with an idea. And they're like, hey, I have this awesome idea. I have this problem that I'm wanting to help solve. How do I go about that and do it? And we provide, hardware samples, funding, software acceleration, data science experience, et cetera, depending on the type of problem that's being faced. And projects can last anywhere from a few months to like a couple of years. So it is really interesting just to hear the variety that's been going on. And of course, there's a bunch of different hurdles that we face. And these last few slides, what I want to help you take away is like, how do you actually do this in practice? How do you get started? And one of the biggest is like getting the right partners together, figuring out if like the solution is going to help what's going on. And a lot of that is having conversations, reaching out for help, getting advice from different communities. And, the logistics then is like, how do we get the right algorithms? How do we make sure that there's legal agreements, funding, staffing, et cetera? And, there are, in terms of like, there's a lot of open source data, a bunch of different open source algorithms. That's one of the things I love so much about AI is that we're all contributing to this area, which is lovely. And in terms of like communities, there's a growing effort in this space. So this mind map was made by an individual, and it's cool. You can sort of see, okay, what are the boot camps, the fellowships, what are the organizations that are working on this, et cetera, the various initiatives, the data that you might want to check out, et cetera. And for everyone, regardless of like what their current status is, like students, if you're a working practitioner, et cetera, there's a lot of ways that you can help out, either in small sprints or longer term. So there's a bunch of different social good volunteer organizations that are out there. These are some of my favorites, especially if you're in the Bay Area. Delta Analytics is a great one. Or if you're more into hackathons or just like challenges to practice, there's stuff like Driven Data, or Kaggle has like a data science for good, et cetera. And there's this job board that I like. Mainly, one of the things that they do that I think is really cool is they have this like weekly newsletter which talks about some of the coolest AI for good projects and programs every week. So that helps me keep up to date. Okay, so that is the whirlwind of AI for good. I just wanted to leave you with a few resources. So there's more projects examples on our website. If you're interested in getting access to compute, we have like the AI developer program, and that's a great way if you have an idea that you want to try out. We have a dev cloud that you can use, and you just sort of sign up for that. It's free. If you are a startup or know a startup that's interested in getting help, there's AI builders. And then all that AI ethics work that I talked about, a lot of the toolkits are at that bottom link. And one of the things that we wanted to mention to y'all in particular is that there is like HPC AI DevCon in November in Denver, Colorado. And so you can reach out to Thomas Kruger, who's over there in the blue shirt, about that. Or if you're interested in learning more, or collaborating, you can reach out to myself or AI for Good at Intel. Yeah, so thank you all. And are there questions? Yeah.